Welcome back to section 7.7. The next thing we're going to do is a current problem. Sometimes you see boats, sometimes you see airplanes. In this example, we're going to have a boat. So this is example 4. In his boat, Dave travels upstream at top speed to his favorite fishing spot, a distance of 36 miles in 2 hours. When he returns, the trip downstream takes only 1.5 hours. Find the rate of Dave's boat and the rate of the current. So the first thing let's do is define our variables. So I'm going to use a b for the speed of the boat. So I'm going to say boat speed is b. And I'm going to use a c for current. So this is going to be the current's speed. Okay? So what's happening is upstream, the current is working against you. You're going against the current. So the rate when you go upstream is going to be b minus c. It's going to be the boat minus the current. They're going to work against one another. Versus when he goes downstream, he's going with the current, and the current's going to speed him up a bit. So the rate when he goes downstream is going to be b plus c, the boat's rate plus the current's rate. Okay? And the general equation we're going to be using here is distance equals rate times time. Okay? So let's make two equations. Let's do an upstream equation and a downstream equation since they're two different trips. So when he goes upstream, the distance was 36 miles. The rate that we're going to use is this b minus c, boat minus current. And the time, it says it takes him 2 hours to do that. All right, downstream. So, in the downstream trip, he returns home. So we're going to assume that he goes exactly the same distance since he's going from the same spot to the same spot. So 36 miles would be our distance. The rate when we're downstream is going to be this b plus c since the current is speeding him up a bit. And it only takes him 1.5 hours to go there. Okay? If it helps, we can definitely distribute both of these to make them a little bit simpler looking. So the upstream current equation, we would have 36, and that would be 2b minus 2c. And with the downstream, I could also distribute that 1.5 and say 36 equals 1.5b plus 1.5c and kind of distribute it that way. We're in standard form, so my reaction to this is probably going to be, let's do some elimination, okay? With 2 and 1.5, the best I'm going to get is for them to be 6 so that they can match and cancel each other out. So what I'm going to do is take that upstream equation that I have, and I'm going to multiply both sides by 3 to get to 6. So let's see, 36 times 3 is 108. 2 times 3 is 6b. 2 times 3 is going to be a 6c. Then I'm going to take my downstream current. If I want to get from 1.5 to 6, I'm going to multiply both sides by 4. So 36 times 4 is 144. And 1.5 times 4 is 6b. And 6c. So now you notice that I can cancel out my c's, which is pretty exciting. So I'll add those equations together. I'll cancel out my c's. 6b plus 6b is 12b. 108 plus 144 is 252. And then I'll divide both sides by 12 to solve for b. So I'm going to get b equals 21. And what does that mean in the context of my problem? It means that my boat speed is 21 miles per hour. So my boat speed is going to be 21 miles per hour. All right. It does say that they want the rate of the boat and the current, so we do need to solve for c as well. Doesn't really matter which equation I use, but how about we use the one that doesn't have decimals in it? So let's just use this one. I'll have 36 equals 2 times b, so that's 2 times 21, minus 2 times c, and we'll solve for c from there. 2 times 21 is 42. If I subtract 42 from both sides, I'm going to get negative 6 equals negative 2c, And if I divide by -2 on both sides, I'll get 3 equals c. And what does that mean in the context of my problem? It means that the current's speed is 3 miles per hour. Okay? So there's your answers. Okay? Now it's your all's turn. You get to try one and show me how much you've learned.